Hi guys, welcome to lesson 11.1, simplifying rational expressions. And these notes were recorded in front of a live studio audience. Our objective for today is that I can simplify rational expressions. What is a rational expression, you might say? It is an expression that is written in the form of one polynomial over another polynomial. Excluded values are any value for a variable which the rational expression is undefined. And we know something is undefined when our denominator is 0.
Our essential understanding. The simplified form of a rational expression is like the simplified form of a numerical fraction. The numerator and denominator have no common factors other than 1. To simplify a rational expression, divide out common factors from the numerator and the denominator. Like a numerical fraction, a rational expression is undefined when the denominator is 0.
All right, problem number 1 is simplifying a rational expression. So we want to know first what is the simplified form of each expression, and then secondly state any excluded values there may be. So looks like we've got 21x squared over 7x cubed. 21 over 7, we reduce that to just 3, and we use our exponent rules, and there are more x's in the denominator, so it's 3 over x. And an excluded value would be x cannot equal 0, because if it does, this would be undefined. Okay. Letter B, we've got x plus 3 over 2x plus 6. So we have x plus 3. We can factor out a 2 from 2x plus 6, and that becomes just x plus 3. So those two polynomials are going to cancel out. We're left with 1 over 2. Our denominator cannot equal -3 because that would make x plus 3 0, and it would be undefined. Okay. Move it up a little bit.
You cannot have a 0 in the denominator. So that's how we found that it was going to be -3. If we put a -3 in here, I end up with a 0. Cannot have a 0 in the denominator. So my answers are 1/2, that's the simplified, and my excluded value, -3.
All right, letter C, we've got 18y squared over 4y plus 8. Nothing we can factor on the numerator, but in the denominator we can factor out a 4 from y plus 8, and we're left with y plus 2. And now 18 over 4 can be reduced to 9 over 2. We've got y squared in the numerator and y plus 2 in the denominator. Now, Mr. Boland, you might be thinking, can we cancel out one of those y's? The answer is no, because the y plus 2 is tightly, it's included in that parenthesis, so it is not separate, not able to be divided. You know, it's part of that plus 2. All right, so our excluded values would be whatever makes that denominator 0. So we
What would make, this 0? The only thing that would make that 0 is a -2. So we want to make sure that y, because I said so, cannot equal -2. This is so much fun.
So I want you guys to try letters D, E, and F on your own, and then we will go over them. So 48y to the 5th over 6y to the 3rd. 48 divided by 6 is 8. Y to the 5th over y to the 3rd. 5 minus 3 is 2. 8y squared. Y cannot equal to 0, because if it does, the denominator will be undefined. Letter E, looks like we can factor something from the denominator and not from the numerator. So we have 2n minus 3 over 6n minus 9. Well, we can take out a 3 from 6n and 9, so it's 2n minus 3.
Isn't that convenient?
Yep. So 2n minus 3 is appearing in numerator and denominator, so it cancels out. Now, we can take that 2n minus 3 and set it equal to 0, add 3 to both sides, and then divide by 2. Or we could go to the original and add 9 and divide by 6. Either way, we're going to end up with n cannot equal 3/2. Okay. Letter F, 26c to the third plus 91c.
Boy, you had fun with those numbers.
I did.
Jeez.
So we can take out a 13 and a c from that. And what we have left is 2c squared plus 7. And in our denominator, we have 2c squared plus 7. Hey, convenient.
Jeez.
Was it really that bad?
It was. You made us think.
That is what I do. That is my job, making you think. All right, 13c is my solution. And
We don't have an excluded value.
there are no excluded values because we are squaring something, we're multiplying it by 2, and then we're adding to it. There's only going to be positive values there. There is no possible excluded value. Nothing will make the denominator 0.
Nothing will make the denominator 0.
This was a bad idea.
No, I like this. This is a great idea.
Problem number 2, simplifying a rational expression containing a trinomial. So again, same directions. We want to know what is the simplified form for each expression. State any excluded values. So we're going to factor everything just like we have been. So 2x minus 8, we can factor out a common factor of 2, and it's x minus 4. Denominator, we have x squared minus 2x minus 8. Well, that's going to be minus 4 and plus 2 as our two common factors. So x minus 4 cancels out, and we're left with 2 over x minus 2. Sorry, x plus 2. X plus 2. Our excluded values we cannot equal. Well, it's going to be whatever makes those two denominator pieces 0. So x cannot equal 4, and x cannot equal negative 2. Okay, so you're going to have what's shown in the box there. That's going to be what has to be shown when you guys are showing your work. All right, letter B, a squared minus 3a plus 2. So we're going to have a minus 3, or a minus 2 and a minus 1. And our denominator, Mazir is already factored. She has 3 times the quantity a minus 1. So those two binomials cancel out. You have a minus 2 over 3. And a cannot equal positive 1. Okay. Letter C, 6z plus 12 over 2z plus 7z plus 6. So we need to factor the numerator. We can take out a 6, and we're left with z plus 2. Denominator, well, we've got an a term, so we're going to have to use box method. Yay! So we have 2z squared. We have a 6. Multiply 2 times 6, and you get 12. So we're looking for factors of 12 that add up to 7. That's 3 and 4z. So when we factor it, we get a 2z plus 3. We've got a z and a 2. So our two terms are z plus 2. Sorry, 2z plus 3 and z plus 2. Our z plus 2 terms are going to cancel out, and we're left with 6 over 2z plus 3. Excluded values, we're going to have z cannot equal negative 2. And z cannot equal negative 3/2. Okay. I want you guys to try letters D and E on your own, and then we're going to go over them. So letter D, we need to factor both the numerator and the denominator. Both have trinomials. So we have
Boy, you left
C.
a lot of room here.
There is plenty of room where I wrote it.
Yep.
So we get C minus 6 and C minus 6 and plus 1? C minus 3 and C plus 2.
Well, that's what I meant. I was complaining about all the room I had left.
All right, and in the denominator, we have C plus 3 and C plus 2. So C cannot equal negative 3 or negative 2. Okay. Letter E, 5x plus 10. We can factor out a 5 from that.
Apparently it's not lime green.
And we have x plus 2.
It's a nice writing pen, though. Kind of like it. All right, so x cannot equal, well, it can't equal negative 2, and it cannot equal positive 3.
Okay. Moving on to our next section, recognizing opposite factors. I want to know what is the simplified form for each expression. So opposite factors, what does that word opposite mean? It means opposite signs, one's positive, one's negative. So here, if we reorder letter A and we write it as 2x minus 5 over negative 2x plus 5, we can see that those are just opposites. We've multiplied by negative 1. So we can take out a negative factor of negative 1 from one of our terms. We'll take it out of the bottom. So we have 2x minus 5
That's a minus.
over 2x minus 5 times negative 1.
Oh, I guess I don't have to do that, do I?
Yeah, because we're factoring out the negative. So we have a negative 1 on the outside. Our 2x minus 5s cancel out, and we're left with 1 over negative 1, which is just negative 1.
Ooh, let's
Okay.
do that one again.
So y squared minus 16, well, that's the difference of perfect squares if I ever saw it. So that's y plus 4 and y minus 4 over, well, if we rewrite that, it's negative y plus 4. So if we factor out a negative from that, we're going to get y minus 4, which cancels out. And so we're left with y plus 4 over negative 1.
Shouldn't that be oh, I see what you did. I did it this way. Or you put your negative out here. We did it both ways in class the other day
Okay. The other day.
on something.
All right, so letter C and D, I want you guys to try those on your own, and then we are going to go over them. So we can factor out a negative 3 from 3 minus 9D, and we get a positive 1 and a negative, or sorry, a negative 1 and a positive 3D. Negative 1. All right, and our denominator we have to factor. So we're looking for factors of negative 6 that add up to 1. So that'd be negative 2 and positive 3. Okay. So we've got 2d plus 1 and 3d minus 1. And we can notice that the 3d minus 1 and 3d minus 1 cancel out, and we're left with negative 3 over 2d plus 1.
Minus 1.
Minus 1, sorry.
Oh.
No, plus 1.
Should be plus 1. You did it wrong on your notes.
All right, fine. Okay. All right, next up, letter D, we have 3 minus 3z, so we have 3 times the quantity z minus 1. Should be negative 3 that you would have pulled out there. And we have 2 times z squared minus 1. Ooh, z squared, difference of perfect squares. Right, Ms. Smith?
I do love difference of perfect squares.
All right, so it's z plus 1 and z minus 1.
Perform before a live studio audience.
This is impressive.
Thank you.
All right, so we can cancel out the 2 z minus 1s, and we're left with negative 3 over 2 times the quantity z plus 1. All right, moving on to our last section, which is using a rational expression. So if a square has a side length 6x plus 2, and the rectangle has a width of 3x plus 1, and it has the same area as the square, we want to find out what is the length of the rectangle. So just a couple things here. If we've got the area of the square, and we're going to divide it by the width of the rectangle, that's going to give us what the length of our rectangle is going to be, because they have the same area, and area is length times width. All right, so the area of our square is going to be 6x plus 2 times 6x plus 2. Okay, and our width of our rectangle, we're told, is 3x plus 1. Well, that's 6x plus 2. Can we factor something out of one of those? I do believe we can. So we can make one of them 2 times the quantity 3x plus 1. So we can cancel out one thing. So we're left with then 2 times the quantity, 6x plus 2, over 1. And we can just redistribute that, and it'll be 12x plus 4.
No units? Where's your units?
Well, it wasn't given any units, so we're just going to go with it.
Last one.
Unit squared.
All right, so the length of a rectangular prism is 5 units more than the width. The volume of the prism is represented by w cubed plus 7w squared plus 10w, and I want to know what is the simplified expression for the height of the prism. So remember, the volume of a rectangular prism is length times width times height. So if we want to figure out what the height is, we should divide the volume by the length and the width. So we write out our volume of the volume formula, and we divide it by the length and width. Well, we need to factor, and ooh, that's factoring a trinomial with higher powers. So we take out first a w, and we're left with w squared plus 7w plus 10. So we have w plus 5 and w plus 2. So those are our 3 terms in the numerator. And our denominator, we have a w and a w plus 5, which both cancel out. So that means we are left with w plus 2 as the representation of the height of the prism. All right, that's the end of the notes for today. Make sure you guys fill out your level of understanding and write down a summary of what you learned today. And please write down any questions you may have come up with during the course of the lesson. Have a great night. See you in class.